Okay, this is Chapter 3, Data Preprocessing and Exploration. So here's what we want to do in this series. To understand, the learning objectives are to understand different types of data from the point of view of data analysis. To understand and appreciate the applicability of operations to data of different types. So once we say there are different kinds of data, which types of operations can we do to which types of data? To understand the origins of data sets and problems associated with data sources. To appreciate issues regarding data quality. To learn techniques for pre-processing data. To observe ways of exploring, visualizing, and understanding data before data mining, and to learn to preprocess, explore, and visualize data in Weka. So input data and data types, data objects, attributes, and measurements. So a data object is the individual. We say it's the individual that you take measurements on. For example, what does that mean? For example, let's take the example of the iris data set. So then the individuals are the different flowers. Each flower that you pick up in the field, each one of those is called an individual. And then you measure different things about the individual, like the petal length, petal width, sepal length, sepal width, and the type of flower it is. So each of those are called variables. Those 5 things are called variables, and they're measured on an individual, and that's what we mean by a data object. A data object is represented by its values for a predefined set of features. So in that case, the predefined set of features are the 5 variables that I just mentioned. If we were talking about the situation with the weather and playing golf, then the variables were outlook, I think it was, humidity, temperature, wind, windiness, and play or not. So those would be called the attributes or the features or the variables. Okay, and we talk about each. So each case or each object would be a particular group of people, I guess. So the first group of people, the outlook was rainy, and was windy, and the temperature was high, and blah blah blah. So that was the first group of people, and so we talk about the first group of people in terms of those variables or those. So a data object is represented by its values for a predefined set of features, attributes, or variables that collectively describe certain aspects of the real-life object or event. So like if you take that flower example, you go out in the field, you pick up a flower, you can talk about its sepal length, sepal width, petal width, and its type, but obviously there are many other things you could describe or talk about with regard to that flower. So those are just certain aspects of the real-life object, right? There are many other aspects of the real-life object, of the real-life flower or an event. Okay, measurement errors. There are different kinds of, we talk about different types of errors. We can talk about bias, imprecision, and inaccuracy. Let's look at this first. There. So here we have, like you're shooting at a target, and we have 4 different examples. So let's look at this example here first. Let's look at the example on the far left, lower left rather. So that's pretty good, right? This person, who's ever shooting, did a pretty good job here, as opposed to this person, or this person, or this person. And we can describe the differences between these. So what's the difference between, say, this person here in the upper left corner and this person here in the lower right corner? So they're both inaccurate. They're not centered at the center, But what's the difference? This one is sort of spread out around the, if you took the center of these, it's pretty close to this center. But if you took the center of these, it's way over here. So these are not, these are close together, so that's a good thing about them, but they're close together in the wrong place. So these are centered in sort of the right place, that's a good thing, but they're spread out. They're not close together. So what we want is both. We want it to be centered in the right place and close together. These over here have both problems. They're spread out and they're centered at the wrong place. So when they're spread out, we say they have a lack of precision. When they're centered in the wrong place, we say they have bias. And to talk about the bias, we can say how much bias there is by measuring the where is it centered and how far is that from here. That's called the bias. So the distance from the center here to here is called the bias. So here is also bias, right? Because the center is here, the distance from here to here is the bias. And then also the precision. And that's the kind of the variation, or like the standard deviation could be a measure of the precision. So when a biased measuring instrument is used, a systematic variation from the true value may be introduced. So systematically away from or not centered around the center. Such bias can be quantified only when the true value is known. So if we didn't know the true value here, the center, we couldn't talk about the distance from the center. The distance of the center here from here, we couldn't talk about that. So we need to know that in order to quantify the bias. For instance, a person's height is measured in meters 5 times by a tape ruler with those results. The sample mean of the measurements is calculated as that. If the true height is known as this, 1.740, the amount of bias is measured as the difference between the center here, the average of these, and this. So this is called the bias. Imprecision is normally caused by not using a sufficient number of significant digits. For instance, using 2 significant digits to measure a person's height is less precise than using 3. The amount of precision can be indicated by the closeness of the repeated measurements. So how close they are or how scattered they are. In the example of measuring someone's height 5 times the standard deviation known as the standard error among the measurements can be used as an indication of precision. Accuracy refers to the closeness to the true value and is related to bias and precision. Inaccuracy can be caused by high bias and also by low precision. Only measurements with low bias and high precision can lead to accurate results. Okay? Besides possible data, okay, let's stop here and do another one.